Alright, so in this tutorial we're going to look at using the sine rule to find a missing side. So I'm going to go through a straightforward example first, this one that I've got here, and then I'm going to go do two past paper questions, one from a calculator paper and one from a non-calculator paper. But first let's just make sure that we can use the sine rule. So I actually already told us we're going to use the sine rule, but you can spot whether you're going to use it by looking for a matching pair. So we're going to work out whether we have a matching pair in just a moment. The other option, if you weren't using the sine rule, if you're trying to find a side, is to use the cosine rule. So just looking at our formula sheet, we've either got the sine rule to find a side, or we've got this one here, that a squared equals b squared plus c squared, etc. This one here for cosine is cos a equals, so that's to find an angle. If we're using the cosine rule, I've spoken about this in class, then we're looking for a cosy corner. We're looking for an angle in between two sides. We only have one side here, so we definitely can't use the cosine rule. So hopefully we're going to be able to use the sine rule. So we're looking for this one up here. Before I get started, I'm just going to label this A, B, and C so that we have corners there. I'm going to write down the sine rule exactly as it's given in the formula sheet. We're looking for a side, and that's already on the numerator here because it's little a, little b, little c. So if we're looking for a side, I'm just going to copy it down exactly as it is. So a over sine A equals b over sine B equals c over sine C. Right, from there, I'm just going to label the sides that we've got because we've not labelled them yet. So across from the angle A is going to be the side A, across from angle B is the side B, and across from the angle C is side C. I'm just going to circle what we're looking for. So here, the missing side with the question mark is labelled A, so I'm just going to circle this A right here. Then I'm going to tick what I have. So I also have the side B, so I'm going to tick that. I have the angle C, so sine C I'm going to tick, and I have the angle B, so I'm going to tick that. And we're looking for a matching pair where we've either circled or ticked everything, but right now we actually don't have that. You've probably spotted already that if we know two angles, we can always find the third angle because we know that three angles in a triangle add up to 180 degrees. So to find the angle A, we're just going to do 180 degrees minus the 85 and the 40 added together. 85 plus 40 is 125. Take that away from 180, 55 degrees. So this one here is 55 degrees. And now we can tick sine A on our formula there. And now we have a matching pair, the A's and the B's, so we can get rid of the C. We don't need that for the rest of it now. We're now just going to write this out again. If A wasn't already at the top left, I would always write what you're looking for first. So A over sine A equals B over sine B. And it just makes it easier to handle as we're going through. So A we don't know, so we're just going to write that again. Over sine A, that'll be sine 55, because the angle A is 55, equals B is 12, this side, so 12 over sine, and the angle B is 40. So we've just substituted in everything that we ticked that we had, those three there, 1, 2, 3. Now to get A by itself, right now it's A divided by sine 55. So we're just going to multiply by sine 55 on both sides. Multiply by sine 55 so that we cancel it out on the left-hand side. We're just left with A equals 12 over sine 40 multiplied by sine 55. I've just written it the side here, but you can write it on the numerator and write 12 sine 55 over sine 40. Once we've got to that point, we just need to put that into our calculator. So A equals 12 over sine 40. Just make sure to close the brackets whenever you have that, otherwise it comes up as an error, times sine 55, close the brackets again, equals 15.292 ... and A equals, we're just going to round that to one decimal place, 15.3, and we're in meters, so 15.3 meters. And that's just a straightforward example of how to use the sine rule. Now I'm going to look at a past paper question. Right, so this one, I think it's from the 2018 paper. So let's have a look at what we've got. in the diagram, angle ABD is 75 degrees, so it's marked in for us. Angle BDC is 37, also been marked in, and BC is 20 centimetres. So they've actually marked in everything that they've told us here. Calculate the length of DC. So let's just label our sides. So B will be there, C will be there, and D will be there. Okay, we're looking for a length. Do we have that cosy corner? Do we have two sides with an angle in between? Well, we've only got one side, so we can't possibly have that. So we're thinking sine rule, but right now we've only got one angle, so we have to look at how we can fill in the other angles. Having a look over here, if we know that that one there's 75, we can always work out the one that's inside the triangle. We're always looking for the ones inside the triangle here. Now, as you can see, that lies on a straight line, so hopefully you've noticed that this one is going to be 180 minus 75, which is 105 degrees. Now you see that we've got two angles, so as soon as you've got two angles, you can work out the third one, because you do 180 minus the 105 plus the 37, which works out at 38 degrees. So we've now got all three angles, which is going to really help us in getting this side. Right, let's go back to what we were doing. So calculate the length of DC. We've not got that cosy corner, so we're instantly thinking sine rule. Here's the sine rule here. This is in A, B, and C. We're working in B, C, D for our triangles, so you can just write it out with the different letters. So I'm going to write out B over sine B equals C over sine C equals D over sine D. So exactly the same, we've just changed it to the letters that we're using here. So we've worked out all three angles, so I can tick all three at the bottom. What is it we're looking for? Well, it's the length DC, and we've labelled this one B, so I can circle that we're looking for this one. And we've also got this one here, we've got D, which is 20, so we can tick that. As you can see, we then don't need C, so we're just going to score that one out. Right, let's just rewrite what we're going to use. We're going to use B over sine B equals D over sine D, and as you can see, I've just left B at the top left-hand corner. It's easier to deal with as we're substituting in. So B we don't know. Sine capital B, the angle B, is 105, equals D, which is 20, over sine 37 degrees. We're going to move this over by multiplying by sine 105 on both sides, and B is going to equal 20 over sine 37 times sine 105. So we've just moved that sine 105 over to there, multiplying by both sides. All right, put that into your calculator. 20 over sine 37, close the brackets again, move the side, times sine 105, close the brackets. So we've got 32.100 dot dot dot. I'll just check if it asks us to round to anything in particular. No, just calculate the length. So we can write B, or actually what would be even better is just referring back to the original question, DC. So not calling it B, we've been asked what DC is, and we're going to write DC equals 32.1 centimetres. And that's you. All right, I'm going to do one more question. This time it's going to be a past paper question from a non-calculator paper, so we're going to see how to deal with that. Right, in triangle KLM, KM is 18, it's given us that. Sine K is 0.4 and sine L is 0.9. Calculate the length of LN. So we've been asked to calculate the length, so we're already thinking cosine or sine, because we've got a triangle. We've also been told what sine L and sine K is, so we're already thinking sine rule as well. Now just be careful here. When you're in the non-calculators papers, they're not telling you the size of the angle, they're not telling you that K is 0.4. They've actually given us what the whole of sine K is. Normally we would write, if the angle was 40 degrees, we would write sine 40, and that would give us something. But if we were to actually write sine 40 equals, we'd get a number. And so we have been given sine K equals 0.4. So you're going to see what to do with that in just a moment. So sine rule we know we're using, so just referring back to the formula sheet, we're going to write it, and we've got KLM this time. So K over sine K equals L over sine L equals M over sine M. Right, which one are we looking for? LM. Let's just label our side. So that would be K, L, and M. So we're looking for LM, which is K. So we're going to circle this. We've been given sine K. We've been given sine L. And we know what L is. So nice and straightforward. We don't need M. Okay, this is where you need to be careful on non-calculator questions. I'm just going to rewrite this out. K over sine K equals L over sine L. So K over, and we're going to replace the whole of sine K because we know what sine K equals. Sine K is 0.4, so we're going to do K over 0.4 equals L, which is 18, over 0.9. Right, so to divide by a decimal, let's just deal with this first before we do this. K over 0.4. Now, we don't really want to divide by this decimal here, so actually if I just change this fraction into a different form, multiply the numerator and the denominator by 10, which is absolutely fine, you can just do as long as you do both, times 10 times 10. We can rewrite this as 180 over 9, and now we can actually do that division, so K over 0.4 equals, 9 goes into 18 two times, 9 goes into 0. So we've got K over 0.4 equals 20. So that means K equals 20 times 0.4. I've taken that over. Now, different ways you could do this. You can just do the multiplication if you want to do with decimal. I actually would probably prefer to change that decimal into a fraction. So 0.4 you could write as 4/10. 20 divided by 10 is 2. Multiplied by 4 is 8. So you might just want to look over some of your fraction work there or decimal work if you weren't too sure of the last two steps. But we've got K is 8, so I'm just going to, in that last line, refer back to the original question because it asked us for the length of LM. LM equals 8 centimetres. And that's you. So maybe have a little try. Look back at the first question. Try a few of the calculator ones before you go on to these non-calculator ones. And you're ready to do sine rule finding a side.